Ladies and gentlemen, distinguished guests and participants, good day. Welcome to 2022 Presidential Hackathon International Track Introductory Webinar. I'm today's facilitator, Ronghua Mi. Thank you all very much for joining us today from around the globe. It is our pleasure to pay our honorable guest a compliment. So allow me to introduce you our VIP today. This year's representative of International Track Implementer, Deputy Director General, Ms. Betty Hu, Small and Medium Enterprises Administration, Ministry of Economic Affairs. Thank you very much for coming, Betty. Betty, we cannot hear you. I think you mute yourself.
Okay. Okay. Hello,
Wonderful.
everyone.
Hello,
Good
Betty.
day and good evening or good night. Okay.
Or good morning. Okay, so we are now inviting Deputy Director General Ms. Betty Hu to give us a welcome remarks. Betty?
Okay. Hello, everyone. First of all, thank you for joining us at the first online event of 2022 Presidential Hackathon International Track. This is the fourth Presidential Hackathon International Track since 2019. As the implementer, the SMEA administration, Ministry of Economic Affairs, encourage hackers to come up with proposals that use open data to combine technology and innovation as well as solutions to common global challenges. Last year, we know that COP26, after that, more than 100 countries have committed to a net zero carbon emissions goal by 2050. To respond the global warming and extreme weather, many countries have made net zero a priority in environmental and climate policies. Taiwan, Japan, Korea, and Singapore are exploring different low carbon options. Renewable energy still plays a role, but it is necessary to invest in new and diverse technologies. Therefore, net zero has become the focus of this year's international track. The objective is to encourage hackers to create tangible solutions and find out what challenges might arise when implementing net zero strategies. Last but not least, I would like to thank last year's team of Excellency, AB Street, for joining us today, and one of the past winners from Keelung for sharing their current progress. We are very happy to see hackers from all over the world interacting with and learning from each other to demonstrate global citizenship and achieve sustainable development. Thank you very much, and I wish the event a great success. Thank you.
Thank you very much, Deputy Director. So, while our Deputy Director gave us the welcome remarks, I believe that my colleague had already shared our code note for today. So, if you're available, please leave your message if you would like to, including if you have any GitHub or email that you would like to share. So the next session of this code note is about discussion notes. So if you have any question during or after the presentation, you are very welcome just to type your question there so we can go through at the end in the QA session. And if you have other related sources about net zero or climate change, you are also very welcome to share on our code note. So, if there's no other questions, I would like to share my screen to introduce you about the 2022 Presidential Hackathon International Track. So just give me a sec. Okay. So can everybody see my share screen? Yes? Okay.
Yes.
So thank you. Thank
Okay,
you.
okay.
Wonderful. So thank you very much for participating in this event. In the next 10 minutes, I'm going to introduce you about what is Presidential Hackathon and what's this year's challenge and other important information. And this is today's agenda we're going to go through. So, what is Presidential Hackathon? The Presidential Hackathon is an initiative designed by the Taiwanese government to demonstrate its commitment and by to employing open data or data innovatively in order to address sustainable development issues and for social needs. It expanded to include an international track since 2019. Participants from around the world were invited to propose open data solutions or data solutions for delivering a better world. So, international track is encouraging teams to form data collaboratives in order to solve challenges together. So the challenge thing last year is Sustainability 2.0 climate action. And as our deputy director mentioned, AB Street, Team AB Street is going to share their experience with you. So I'm not going into details here. And spoiler alert, we're going to invite another team of excellent office farmers to share their experience. So please stay tuned. So, about this year's challenge theme, it is climate action, practicing net zero. So, anyone who keeps an eye on climate change would be very familiar with National Determined Contributions, aka NDC, which is also an important conclusion made in COP26. There are more than 140 countries submitted their new or updated NDC, and that number nearly accounts for more than 57% of global emission. While continuing this number grows, we also need to face the fact that the endorsement of NDC by countries does not necessarily transfer to GHG emission decrement. So, on the other hand, there are more than 56% of global population lives in cities, and there are some major structural systems consume CO2 budget that the urban resident involves on daily basis. Energy, transportation, buildings, waste and sanitation, water, foods, these are just several examples that we can raise here. We encourage hackers to utilize open data or data to raise proposals to help city to become as a functional action unit on the decreasing GHG emission. And here are the important dates that we would like to share with you about this year. We will open the application in the mid of April, which is expected to be closed by late of May. And after first round of judging process, we shall announce team of acceptance in early June. Then the finalist events shall fall in the middle of June to July, which makes the final judging falls in late of June. So, since all participants' health is our concern, we will follow the pandemic situation, or we'll keep an eye on the situation closely and react accordingly. If the border entry policy against COVID-19 allows us to invite team of excellence to travel to Taiwan, we will be delightful to invite them to Taiwan and participate in the award ceremony, which may be late of September. So once the organizer approves the exact date and time, we shall make an announcement on our event website. Here are some elements that we would like to raise your attention if you want to make a submit a ideal proposal. On the boxes on your right hand are elements that we would like to ask you to. It's a must-have. For example, your proposal must be data-driven. It has to be information technology enabled, and please tell us the project status, whether if it's just a concept or you're developing it, or is it already in operation or published. And all your deliveries are has to be in English. On your left hand, the boxes tells you those nice to have. For example, if it would be nice to have the potential to deliver a high impact proposal, if it could include cross sector or cross country collaboration, if it can have a short-term deployment potential, because bear in mind, we don't have much time, run to net zero before 2030 or 2050. So timely matters. Okay, so here's the selection criteria. There are three aspects. Please check out the event website, and you'll see some guiding questions according about the each guiding selection criteria deliverables. So if your proposal, if you choose to choose a generate proposal, please consider if you can create a new or better open data tools or gathering for net zero. If you choose to make a prototype proposal, please consider if you can create new or better tools for open data or data effectuate net zero. Of course, hackers are welcome to have to make proposal that includes three types mentioned above. So if we take a closer look on the selection criteria, you will see that these three dimensions will penetrate all the journey of Presidential Hackathon International track. For example, if you take a closer look on each guiding question, one can see that this question employing theory of change and strategic actions one need to take in order to make a real or in-time impact to run the proposal into a ready-to-go project. So you're highly recommended to take a look at these questions and discuss with your potential teammate. If you can answer these questions, it means you're ready to submit your application. And here's are some do's and don'ts we would like to remind you. Again, all the documents must be written in English, so it could be judged and scored, of course. And the maximum of a team should be no more than 5 members. A team must tell the project real status as mentioned above. And the judges of this year's international track is not eligible to make any proposal. So what's in to raise a proposal to submit proposals in international track? First of all, you will win a cup from for your team and from the president, and you will win the opportunity to present your project at the presidential office building. You will also win the opportunity to join the international program in Kaohsiung for future collaborations or project landings. And how to apply once when the application page is ready, and please visit our website for more information and, and click application button, save or send when you're ready to go. And that would be a very short introduction of this year's Presidential Hackathon International track. If you're looking for a teammate, civic hackers, please screen the QR code that we show now, and you will meet other hackers, including today a B Street speaker. So, Dustin, if you're online, would you like to unmute?
Yes, hello. Can I also screen share?
Sure, please do. The floor is yours.
All right, thanks for inviting me here today. I'm Dustin Carlino, and I entered the International Hackathon last year with this project called AB Street. And I've worked on AB Street for a bunch of years with other people listed here, and so I'll just tell you a little bit about it today. So to motivate AB Street, I guess the problem that I was focusing on is that most cities around the world are far too dependent on people driving cars to get around for transportation. And so this has a bunch of externalities. Of course, climate change and greenhouse gas emissions are one of them. But even if everybody sort of could switch to electric vehicles immediately, that wouldn't really solve the problem of noise pollution, air quality, even from like heavier electric vehicles rubbing against the road and causing like emissions from brakes scraping against things. And then like cars take a lot of space to park. They tend to occasionally have collisions and cause a lot of destruction and injury. And they also encourage a lack of exercise and sort of contribute to a health crisis. So the of the many answers to sort of improve transportation in cities, I think a particularly compelling one is to convince people to ride bikes. These statistics are from the U.S., but there are similar cases in other places. So, for example, in the United States, about 60% of all trips made by car are under 5 miles, which is a distance that would be very easy to ride by a bike or an e-bike. And so, and in addition, like owning a bike and operating a bike is much cheaper than owning a car. And the infrastructure to sort of make it safe to bike would be very quick and simple to build out. And so the question is, if it's so easy, like why don't people bike today? This is a video I took in Seattle um, of yeah, a situation in which it's like it was a situation where it's very unsafe to ride a bike because of the way drivers behave. And you'll notice that there are cars parked on both sides of the road here. Even though this is sort of a major route used by cyclists, like there's no dedicated space for cyclists. And so um, in order to sort of improve the situation and convince more people to bike, it's important to build infrastructure dedicated for cycling and make sure that it's safe. And we know how to do that. Places, particularly in the Netherlands, are famous for having excellent cycling infrastructure, and many people cycle there as a result. But the problem is if you try to propose building this kind of infrastructure in many places, you get a lot of pushback from people that just want to keep driving cars. And they give a lot of arguments that have easy rebuttals, but it's still not a debate that goes very well. And so I think part of the problem is how changes to the street are communicated. People tend to use static graphics that show overall cycle networks. Maybe they will give you a lot of detail, but it's in ArcGIS, and this is not a map that would convince anybody to or any ordinary resident to change the way that the city's transportation works. Sometimes they'll give you a great amount of detail in the sort of changes that they make, but it doesn't really, like, none of this helps people helps residents understand what the changes will do, which is that, like, let's say that somebody is proposing closing a road to car traffic and only allowing buses, trams, and cyclists or something. Like, somebody who insists on driving anyway doesn't care about all of the other changes, or it doesn't care about the details like this. They just want to know at the end of the day, like, how will this impact their trip? This is the thing that people are very familiar with. And so to sort of try to solve a lot of these problems, back in 2018, I started a project called AB Street, which is software that aims to uh, help people explore transportation changes in cities a lot better. And so it has a few purposes. One is that, like, once city planners come up with an idea, they can sort of explain the changes and educate the public about it much more effectively than just pictures that don't let the public explore the idea interactively. And then from the other end, you can ask the public, like, what, if these plans aren't good, how would you do them differently? People tend to be like local experts in certain places. And yeah, so AB Street is sort of a very large project today. It started out as just a traffic simulator, but we've also expanded to sort of focus on a bunch of different areas. And for the hackathon last year, the new component that we built was for planning cycle networks. And I'll quickly go through what some of these look like. So in the beginning, AB Street sort of started out as a way to take a road and just redesign the space along it. So originally, if this road had 2 lanes each way for general purpose cars and buses, like, we can take one of the driving lanes and add in a protected cycle lane to encourage more people to bike on this road, and just really intuitively see how the space on the road could be used differently. And similarly, if there are traffic signals and people know that a particular turn backs up, or it's unsafe for people crossing on foot, there's a sort of an interface that tries to make it easy to retune these things and make quick adjustments. And then on top of this, we try to run a traffic simulation. So you see individual cars, pedestrians, and cyclists sort of moving around the space, and they'll, of course, they'll use the changes to the road and the traffic signals that the previous slide showed. And so the idea, if all three of these things sort of work, is that we could run an A/B test and say, let's try to run exactly the same traffic simulation before and after changes to the map, and then measure things that people might care about, such as delays and travel time impacts, and then also the sort of amount of risk exposure that somebody experiences, or even in the future, maybe the, like, level of air quality that they experience along their trip. And then in principle, if everything sort of works out, then we can measure exactly how the changes would impact individual people. And so the tool that we built last year for the hackathon, so the traffic simulation and sort of the ability to edit roads in great detail is useful, but it doesn't help it's sort of very complex to learn. And so based on that feedback, the project that we built last year for the International Hackathon is called Ungap the Map. And so it lets you quickly analyze the existing cycle network of a certain city. You can plan a route between two different points and sort of see, based on today's conditions, what's the fastest route to bike. But then if you don't want to bike on high stress roads where there's no, where there's a risk of collision with the car, you can find a route through quieter streets. And usually it's the case that it's a lot slower and more roundabout. And in places like Seattle and San Francisco, you have to climb a lot of hills to sort of go out of your way to avoid car traffic. And then the tool lets you quickly sketch out the roads that are important to important in your mind to be part of the cycle network, and you can sort of modify them quickly and add in cycle lanes. Then based on all of this, there is an attempt to sort of predict how many people might switch their trips, from those short trips under a couple kilometers and decide to bike instead of drive because you've made the route safer. But some other projects that we focused on in the past, there's a tool to analyze the concept of 15-minute neighborhoods, which is all about exploring the relationship between transportation and land use. So if people live, if it's a few minutes to walk down the street and go to a convenience store, go to a supermarket, and like go to all of the or go to many of the services that you need to access on a daily basis, like there's no need to own a car in the first place. And so this tool sort of helps you understand in detail, is an area a 15-minute neighborhood or not, based on the different amenities available that may differ for certain people. And then you can also sort of use it as a form of a walk score and say, like, on the right is showing all houses that are within a 15-minute walk of at least one childcare facility and one supermarket. And you'll notice that most of the houses there are not colored red, meaning they're like somebody probably has to drive to access those services if they need them on a daily basis. And so you can see how land use and transportation kind of impact each other. And then we've also spent a little time trying to educate the public about the concept of 15-minute neighborhoods. And instead of sort of a very dry map that is just tries to be informative, we've tried making an arcade game that sort of forces you to plan an optimal route to deliver presents around the city, and you have to refuel from places that sell food. And so when houses and commercial areas are very far apart, you have a harder time. And the same idea is also explored. So with Robin Lovelace and some other collaborators in the UK, there was a project called Active, and it shows new residential developments being built around England. And you can see, just based on the existing network, are people there likely to drive or to walk or cycle or take public transit, just sort of based on the existing characteristics. And so it tries to estimate, are new developments actually going to meet sustainability goals, even if the buildings are very energy efficient. If they lock people into car dependency, then it's not really working out. And we sort of integrated AB Street as a detailed layer, a simulation layer into this project. And then I'll show you a little bit of the work that I've been doing more recently. So I moved to London and joined a group called the Alan Turing Institute a few months ago, and the project there has been focused on low traffic neighborhoods. So low traffic neighborhoods are motivated by people using their mobile apps to route around traffic on main roads. Like if the main road is backed up and you're driving, and your phone tells you that you can save some time by cutting through a neighborhood. This is sort of great for the driver, but everybody living in that neighborhood now has a lot of traffic taking shortcuts through. And this is a particularly bad problem in the UK, where air quality issues are very noticeable. And so in response to this, planners will place these things called modal filters in the street. And this just stops cars from driving through. But if you're on a scooter or a bike, of course you can still get through. And so if you take if you close a single street, of course you expect traffic to kind of vanish along that one area, but you might just move the problem down a little bit. And so this new project that we're working on lets you sort of analyze that. And so if the circles are sort of the filtered streets that I showed you before, and you'll see that there are this is a real neighborhood in Manchester where they placed a bunch of filters to try to stop this problem. But a lot of the filters don't actually help. And so this tool lets you see that really quickly. And if you add a new filter, you'll see the color changes indicating that it's impossible to drive between like you can no longer take this route from east to west. And so this properly solves the problem of traffic trying to cut through a neighborhood when the main roads are backed up. So I do want to mention that the AB Street project runs everywhere in the world thanks to OpenStreetMap data. But of course, there are many different styles of designing roads and ways of mapping data in OpenStreetMap, and some particular challenges in using AB Street in big cities in Taiwan are I would say like the number of large roads with very complicated junctions are like there's a fair number of them in big cities, and the software doesn't really work very well with this. And so, for example, at these intersections, this is a single intersection with one traffic signal logically, but in OpenStreetMap it's split into about 10 different pieces, and it's sort of very difficult to merge this automatically on the software side. And so because of these challenges, it's hard to get good results out of the simulator there. You'll also notice that like it's coloring a lot of this area as if it's a protected cycle lane. It's actually a space mostly for pedestrians, but some people will cycle along it. But the software doesn't yet understand that. And then also the way that people take, I think, either left or right turns is called a hook turn, and the software so far like doesn't have support for this sort of thing. And so if you wanted to try to apply AB Street in the context of Taiwanese cities, there would be definitely more work that we have to do. So a bit about how the project works from a technical perspective. It's based on OpenStreetMap data and also other public data, depending on a place, particularly to understand where people are trying to take trips in the first place. It's written in a programming language called Rust, and there's sort of a core set of libraries to draw everything and to simulate the traffic. And then on top of that, the different apps that I showed you are all kind of built. And then because it's written in Rust, it'll compile to like a native desktop application, and you can also compile WebAssembly and run it directly in your web browser. And so project logistics wise, I've been working on this for a few years, and then a bunch of open source contributors have sort of floated in and out, and some of their names are here. And then also, this is a little bit run as a research project, and so about I think we're up to 4 different master's students in universities have done some kind of project with AB Street, and their skill set sort of spans software engineering, transport planning, and even and design. And then now through my work at the Turing, I'm starting to collaborate a lot with different industry and government partners, and yeah, so if you're interested in using AB Street, maybe not directly, but some of the code for might be useful in your project, if you want to understand road space in detail, we're starting to take the code and split into different pieces. And so there's a few projects linked here. But in short, if you're using AB Street and you realize you want to use one part of it but not all of it, then get in touch and we can figure out how to make it a separate library that's easier to call from your code. And yeah, some of the next steps that the project that I'm hoping to take the project. I want to focus on public transport and give people a very easy way to quickly sketch out new bus and tram routes, because that's another very low cost way to get people away from driving cars, especially in rural areas where like the distance might be too far to cycle every day. I'm also trying to build tools more generally to understand census data. So depending on the country, there's really good open data about how many people live and work in a different area, and really good breakdown of do they own cars, or do they own a vehicle? Where do they work? What sort of transportation needs might they have? But it's difficult to sort of work with data across different countries. So I have some ideas there. And then I'd also like to make it easier to take proposals in AB Street and actually share them. Today, it's a very clunky process, and so that needs a lot of work. And then I mentioned before the modeling of pedestrians and footways is also an area that I'm trying to expand. And so if any of these things sound interesting, or if you have another idea how AB Street could apply, please get in touch, and we can kind of explore possibilities there. Yeah, you can find a lot more information in these places. Feel free to reach out, even if you're not interested in AB Street, but you have another project using spatial data, particularly OpenStreetMap. I'm happy to sort of brainstorm and help out. Thank you.
Thank you very much, Dustin. So I would like to come to our code note again. If there's any participants who join us later recently, please visit our code note. And if you were willing to leave your message, your personal message, so perhaps you can contact with each other. And if you have any question to AB Street or this thing, then you can also reach him over there. And I see there are two questions. We will come back to AB Street later. And now I would like to introduce Team Hacker Planner. They are one of the winner in this year's Keelong Hackathon. So, Mr. Zheng, are you there? Can you hear us?
Yeah, I'm here.
Wonderful. So the floor is yours.
Okay, can you see the screen?
Yes, we can.
Okay, hi everyone. Thank you for your introduction and inviting me here. It is my pleasure to join this meeting. And today I will introduce our Hackathon project, Track Transformation, the intersection of AI and Keylong data. And before we start, here is a little bit about our members' introduction. We are from Sinotech Engineering Consulting Company. I am Dechen, and Jeffrey and Benson are here. Our expertise including urban planning, industrial park design, and also spatial data analysis. And talking about spatial data analysis, nowadays we are living in a golden era of Earth observation, EO. And basically, we are able to get the global Earth observation data from various possible sources. And a lot of data are being provided openly, free, and with long-term perspective. So in this project, we are trying to propose a new framework for spatial planning that using Earth observation data, open data, and AI. And our research area located in Keelong River Corridor, which including 6 urban planning area, is lie across the boundary of Keelong City and New Taipei City. So how do we envision the site? In order to seek out the spatial issues and the potential of our study area, we using the text mining technology to dig out the official reports, including spatial plan or as per meeting minutes. So in our result, the result shows that in the urban planning sector, put a lot of effort into discussing about location, industry, transportation, and conservation. So therefore, our task force on strategies for industrial transformation. And we need to understand the spatial development, industrial potential, and the transportation accessibility. Meanwhile, we want to share our thoughts on ecological and digital governance. So how do we observe changes in spatial development? Here is a 50 years long-term satellite image in Keelong River Corridor. Here we can see the early development centered in downtown Keelong and then gradual sprawl along the Keelong River Corridor. But how to further the quantitative analysis? We can using the artificial intelligence and the Earth observation technology to observe the spatial changes. First of all, we need to collect the satellite data of our study area. Then we prepare a train data set. We split the data for 60% for training and 40% for validation. Then we reshape the data and continue the normalization. Next, we adopt the deep learning model, which is a multi-layer perceptron. Then we tune the hyperparameter to reduce the overfitting problems. Then we check the accuracy and predict. In other words, we are able to turn this kind of satellite imagery to this kind of building footprint. And our accuracy are over 95%. So first part, let's see the spatial development in Keelong. Here we can analyze the development ratio change over time. In 2000, the development rate is around 70%, and in 2010, it goes up to 84%. and currently is around 88%. So we can analyze the proportion of development in this way. Next, we can overlay the building map. Here is a spatial development in 20 years. The dark yellow indicates the development is more recent. So we can use this data to identify where the urban development located. Besides, we can compare it with the industrial park to understand where the growth goes faster and where it's slower. The second part is industrial potential. In order to understand which location has higher potential, we observe various big data, including manufacturers, population, land use, etc. So first, we examine the factory growth. In 2010, the growth rate is around 20%, and in 2015 is around 25%, and currently is over 30%. So we can see manufacturers grow rapidly over the past 5 years, and new factories are clustering in the river corridor. Besides, we also found that traditional and technology industry are the dominant and primary industries, and is congregated in early built industry park, which could be the priorities for industry transformation. So here is our industrial potential map. The darker orange indicates the industry is the dark orange indicates the higher potential. So in the past, there was a lack of correlation between industrial data and the built environment. So it is important for us to build a bridge between these two and provide a different perspective for future economic growth. Next is transportation accessibility in Keelung. In order to understand the connectivity of the street network, we using the spacing test method. We also want to know the distance to public transit. We perform the service area analysis. Here is our third outcome. This is a transportation accessibility map. The yellow area indicates the better accessibility. So here we could using this map to help us to formulate industrial strategies. Next, after a series of analysis, we are trying to combine spatial development, industrial potential, and transportation accessibility. In other words, we try to connect the data analysis to development strategies. In this map, here you can see 3 types of area. The red area is high suitability area. It can play the leading role in industrial development. For example, the technology industry could be further developed in this area. And the green area is a high industrial potential area, where it's less accessible but attractive for industry. So less place could be suited for traditional industry. And next is blue area, where is high accessibility area, which is nearby transportation infrastructure and with high connectivity of the street network. For example, it would be the proper location to develop the logistic industry. So after talking about industry development, how to find a balance between economy and conservation. Here in the fourth part, we using the satellite image to understand vegetation changes. Here we can calculate the RVI ratio, which is a vegetation index. We calculate 2000, 2010, and 2021. And here is the so in this, here is our outcome. We can identify the vegetation change types. So here we can see 3 types of vegetation change, including loss, no change, and better. So the government can make ecological conservation for the large area. Therefore, we can propose our digital governance platform. First of all, the government can invest the industrial need for the private users. Then the government can provide industrial strategies like we propose. But how government to review the development? Here, we can use the AI and EO technology to check the development and adjust the strategies. On the other hand, the government can release the ecological conservation location, then where can be adopted by the industrial users. For example, if someone wants to build an industrial park, then they need to do some restoration for environment, like to plant some trees in vegetation loss area. And how does the government review the conservation? We can using the satellite image analysis to check the conservation. So the both public and private sector could benefit from this model. And to sum up, in this project, we are trying to propose a new framework for spatial planning. We're using text mining technology to seek out key issues and using the Earth observation and the AI technology to understand urban growth and vegetation change. And we also using social and industrial big data to identify the industrial potential. Then we conclude some industrial development strategies and connect it with the digital governance platform. So at the end of the day, we hope to provide a new insight for city planning, and during that, we can reimagine urban with brilliant data. Thank you.
Thank you very much, Mr. Zheng, and to Team Hacker Planner. So before we move on to Team Aurelien, I would like to especially mention that we have 8 foreign participants from Japan, Mr. Kobayashi Atsumi. I understand that you are very concerned about the energy. So if there's any question that you have in your mind regarding Taiwan's related project or proposal that the team just mentioned, please don't be shy and just type it up in the call note. Okay, so now next team, Aurelien, are you there?
Hello.
Hello. Would you like to share your? Yes, please do.
I'm sorry. Can everybody hear me?
Yes, and the floor is yours. Please feel free to share your screen. Thank you.
I'm sharing my screen.
Yes, very clearly.
Okay. Hello, everybody. I'm Huang Wenshao, and we are one of finalists team in the Kaohsiung Hackathon game. I don't know. Okay. Sorry for my English because my English is not very good. So if you have any question, happy to write down on the internet and we can discuss later in the Q&A time. And let me dive into our concept of our idea. Okay. First, you can see our idea is called an environment cleaning system, but that's just okay. Okay, here's the table of contents. So right now we are going to talk about the first chapter. We are going to talk about problem solution, and second, you see, and third, our work, and fourth is our consultant. Yeah, that's okay. So first, to introduce our team we call us Aurelien, but it's the name is nothing that matter. But the thing that matter is that our most of our team. Well, when I say most, is actually our team member is not actually a hacker because we don't do the software thing. We are from the Department of Mechanical and Electronic Engineering and in National University, National Taiwan Ocean University. Yeah, and we come to participate in this hackathon event is because actually we just want to have some fun. Yeah, but let's deep into our idea of how we start this thing. The problem. Okay, the problem is when we live in Keelung and we go to the mail code 9 market and we find a lot of trash that just lie around, or the trash can is basically just full. Yeah. So this kind of circumstance and this scenario, I don't sure that pronounce. Okay. So this sense just giving us a problem, a question in our minds, just like why no one comes to clean this trash when the trash can is full. And the question is how we started to deliver just start. This is a question we start to think about solution. Yes, and so our idea of the steel solution is something that we call super bin. Yeah, you can also call it a super trash can. Okay, so basically we idea build a model that called super sure, and it has a function to detect the trash to tell whether it's the full or it's about to full, like it's 70% full, something like that. And then we just send the data back into the cloud, and the cloud means some the data just send back into the cloud and some server, and the cloud is the server. I mean, and when those data was in a server, you guys are hackers, so you hacker do your software thing to give an analysis, and then you just throw back the information like into our phone, just like that, like what you see. And that's how we think that it is going to solve this question, this problem. Yeah. And our idea of function that it will make is that it can give us, because the information of if we deploy a lot of those things and we collect data of the trash, then we can make this kind of map to tell which kind of which place is more consumption intensity, because if you consume a lot, you create a lot of garbage. So that's why we think about one of its ideal function. Yeah, and let's see about the potential market and the target. Okay, here we go, because our questions start with the 9 market. So the first potential market is basically the 9 market in Taiwan. So basically, you can see because I'm sorry, it's in Chinese, but you can see every yellow colors word means one city. So basically, it has a lot of 9 markets. So it basically has a lot of potential markets. So that's first station. But also we think that the other thing is, garbage just everywhere. So if you put a garbage can in school, so it can also be used in school. Is just, for example, our college. Yeah. And also the bus stop, because sometimes if you live in Taiwan, there's a lot of bus stop, and actually near the bus stop, there maybe will be a public trash can. Yeah, and we think you may put the super bin system in that, some sort. And if we look bigger, you can see Keelung City and Taipei City, and basically every place where the trash can be put, then there's the potential market. Yeah, and our targets right now, potential ideal target is about government and some recycle company, because they may need this system to tell them that this where the trash can is about to full or is full. Yeah. So basically, the first thing is potential target is government, and government is where they send our garbage truck, and garbage truck in Taiwan is showing here. And basically, we just think this system will help garbage car to know it's time to go. It's not because well, actually in Taiwan, the garbage car has this timetable, so they just arrive at like 7 p.m. and sometimes they just arrive. Yeah, but I think if we use this system, we can just inform the garbage truckers in time information, so that the people don't need to like line up to throw the garbage, yeah, and create a lot of chaos. And the other thing is that when the public trash can is full, then our device will automatically send a signal to the government, someone who take care of them, so that we don't need to see the right picture that is so much full. Yeah. And yeah, that's demonstration of our swapping, basically just sensory. Okay. Okay, then about the other potential targets, recycle companies. So right now, because everybody talk about recycling so much, so they actually there's a recycle company. So we basically want to, if this project can work bigger, we just imagine we can put this sensor into this trash can. So it's in Japanese or something. Yeah. So basically, we just give you the data of the in-time data of the trash full amount. Okay, so that's enough for talking about the ideal. Then let's go to what we worked so far. And here is the video of our prototype. Basically, you can see here is these sensors can detect the high altitude of this object, and we want to put this sensor into the super bin, the super short, the last picture we show you that actually we draw it a 3D model. Just we put this sensor inside, so it will get a data like right hand. Yeah. Okay. So basically, you just work with this 4 part, and this 4 part will just detect and single and calculate the result and send back to the cloud, to a server. And if we look for these systems, we want to, first is for sure that's basically the sensor, but it was local. Oh, why do I call it local? Because last time you see those devices that we put it together is about, well, I will say like 35 US dollars below. So if you just make a manufacture, so you will be, I think it will be quite cheaper and fast to deploy. Okay, but our idea didn't stop that way. We also make bigger is that we make super bucket, and you can protect. You can put more sensor in it and more mechanic unit. Can do more things. Eventually, want to something we call super bin that we just too lazy because actually do the all garbage trash thing. Yeah. Okay. So, and this interface that we give you an idea that actually we just made, but it doesn't actually function. So yeah, it's all what we want to let you think that maybe in the future you will look like this. And to give you the summary of all my presentation is the answer, but actually is, okay, it's a question that we say answer, yeah. If the sound is something hard to bear, why not dealing with it before adding up? You get an idea. Just we give you before we make it out to the garbage mountain. Why don't we just, to do some research before it was garbage mountain? Yeah. And thanks for our consultants, these professors, but well, we just kind of like little talk to them. So if you ask them, maybe they don't really know us. That's all. Thank you for your listening. Thank you. And yes, it's our, well, just, I know, the Gmail.
Thank
Okay,
you
thank
very
you.
much, Mr. Huang. Okay, so that would be three teams that shared their hacking experience today. And as you can figure it out, that all of them provide their solution from different challenge theme and different dimension. And I think that would be all for today. And I would like to again ask all participants to leave your personal or public information so other hackers can contact with you later on. And if you would like to provide your PPT slide for your team or your project, you're very welcome to leave it on our shared code note. It would be public to all the participants today. And of course, the organizer and implementer, Ministry of Economic Affairs. And thank you again for your participation. And I would like to also appreciate my colleagues and all the support from Ministry of Economic Affairs. We will contact you again with our next webinar.